for the game development club. So actually, the bulk of the game was created by the team, mainly by one person called Min Hian, who did the background. So this is how the game will look like. Okay, so there's like a hippo that will chase you on the screen. Okay, now the hippo AI has not been coded yet, but when coded so today we will be coding this hippo to chase the player, and then after that, your aim is actually to find these like crystals, collect them, and then head to the door. And then once you do that, you win. So it's actually supposed to be like a horror game. So the if we turn on the lights, or rather we make the entire screen dark, this is how it should look like. So you have a player going around the grid. Okay, so this is the player. Then you have a flashlight which you can on. Then you need to like sort of search for where all the crystals are. And then see over here. And then after that you need to hit for the exit. All the while avoiding the hippo. Because if you hit the hippo, you will die. Yeah, so this is the game so far. So today we'll be doing the AI for the hippo. Okay, so let's start. Okay, so in terms of I just turn on the global lights 2D. In terms of the hippo wise, the hippo is here. Okay, so this is under enemy, and then the transform for XYZ. You can take a look. So at the top grid, okay, I need to align it to the reference grid for this. So the hippo should take exactly one square only. So if we look at the Hippo Collider. Okay, so we want to make sure that the collider only takes one square worth. We go to the tile map here. I might need to make the hippo smaller so that like if we were to make the hippo position maybe at 0, 0. Okay, this doesn't matter. Okay, so this is 0, 0. Look at the tile map. We will have the yeah. So this is -7. I just want to standardize the position. So 0, 0, 0 is in the center here. It's not exactly like standardized to the grid itself. Okay, because the grid itself, the center position for the grid is at 0, 0, 0. Okay, so we need to tie down the grid system first. So I would expect the player to be here. Okay, so it means that it isn't exactly like the grid isn't exactly very well defined because while each grid does take a value of 1 units, the player itself is not centered on the grid directly. So you can see that the player itself is not centered on the grid. So if we put this player on this grid square here, okay, this is one grid square, the player would not be able. Okay, we want the hippo when it collides with the same grid square as the player, then we want a game over. So we want to make sure that the collider for the players and the hippo can fit within this square. So let's take a look at the collider. This is the collider so far. Okay, so actually to make life easier, we can just create a new game object. Maybe 2D game object sprite square. I'll just make this in maybe order layer 3, and this still be 1 1. So this will signify 1 unit square. So in 1 unit square, this fits. Hippo is a little big for 1 unit square, so we will need to probably scale down the hippo a bit. So let's do some scaling. So over here, we just set the scale to be smaller, or we can just go to the sprite sheet and change the sprite sheets. So in terms of the hippo sprite here, the pixel per unit, we could increase it maybe to about 50. Yeah, that's a bit too small for the hippo. 40. I think 40 will be good. Okay, then if we look at the sprite that I created over here, look at the sprites. This sprite should fit the hippo just nice. Yeah, so let's take a look at the hippo again. The hippo collider. The hippo collider should fit well within this 1 unit square. So as of now, it's a little too much. Okay, because we don't want the hippo to like collide when it's in the unit square. So if we were to shift the hippo down, okay, so this should be good because this fits exactly in the unit square. I mean, actually, the hippo can be slightly bigger as long as the collider occupies the width of 1 square. It's fine. Yeah, then this will mean that we can shift the hippo around and it will not collide with like all these trees and everything because all this take up a unit square as well. So because we are using tile maps here, so we just want to make sure that if we make the hippo move, it doesn't collide. Okay, so now the next issue is that the position itself for the hippo or this is not exactly centered at 0. Okay, so one way to do this will be to shift the entire scene, okay, and then make the starting grid here at 0, 0. That's one way to do it. So we could align this grid here at 0, 0. So if we were to do this 0, 0, 0, oh, what happened to my hippo? I think the z-axis I shouldn't change it. So let's say we put at 0, 0, 0 like that. So if this were to be my 0 position, okay, I could offset my grid accordingly. So in order for my grid to make this at 0, 0, I can just offset here maybe 7, 7. Oh, sorry, 7 minus 7 minus 6 minus 5. Yeah, so we just need to offset so that the hippo is at 0, 0. So this is the hippo currently at 0, 0. So I just need to make my grid. I can apply the same offset actually to the, so all these interactables, okay, I could probably put it in the grid itself so I can offset everything together. Let's try the interactables. I drag it under grid. Okay, then I can offset the entire thing so that I can make my pixel position at 0, 0 for the top left. Actually, maybe my 0, 0 should be at the bottom here. Okay, so that this will be 0, 0, 0, 1, 0, 2, 0, 3, 0 if we use the x and y coordinates. So this will be 0, 1, 2, 3, 4, 5, and then here will be 0, 1, 2, 3. So this square will be 0, 0, this square will be 0, 1, this square will be 0, 2, this square up here will be 1, 0, this square will be 2, 0, 3, 0, and here will be 3, 1, 3, 2, 3, 3. So we're going to do a grid search for the shortest path for the hippo to go directly to the player itself. Okay, so let's just do some offset for that. So my hippo is at the 0, 0 position. Okay, let's. Oh, my enemy is under interactables also, so that's not exactly a good sign. Mm, yeah, I should make my enemy go out like the player and not be impacted by the and not be impacted by the interactables, so that I can anchor it at 0, 0. Maybe the player can be maybe at 5, 5. Okay, so assuming that's the case, okay, let me just adjust my grid accordingly. So I believe I need to adjust to a 0.5 position, and then the y will be 2.5. Yeah, okay, that's good. So now the hippo, after I adjusted all the interactables, the hippo is now at 0, 0 position. Okay, and then let's just take a look at the hippo's collider. Okay, to just make sure that the hippo doesn't collide with the, very good, it doesn't collide with the objects at the bottom, hopefully. I mean, we can make the Hippo Collider smaller a bit. Just drag the collider to be a bit smaller. Maybe the Capsule Collider could be a little smaller so that we give the player some chance to like that. Yeah, then this will assure that my collider is always within the. So at 0 0, this is my hippo position. So we can treat this as an entire grid itself: 0 0, 0 1, 0 2, 0 3, 0 4, 0 5, 0 6, and then we can move like 1 2 3 4 5 and 5. Yeah. So this will be the grid coordinates for the hippo to move. Okay, so that settles the hippo's movement. And then now for the player, we can make the player start at the door, I guess. So there'll be 1 1 6. So you can see that here is from 0 to 6, and then the x-axis will be from 0 to 15. Yeah. So 0 to 6 is for the y-axis, and 0 to 15 is for the x-axis. And all these trees here, we will need to like hard code um, the obstacle directly in our code. Okay, so there's a few ways we can do the AI. One way is we could just make the hippo go all the way to the top or all the way to the bottom, move to where the player's x coordinate is, and then move to the player directly. That's one way to do it. Okay, that way is probably the easiest. You just move all the way to the corner, move to the player's x coordinate, and then move to the player. Okay, the other way is to do the grid search one by one, where we actually shift the hippo all the way to like a certain x or y coordinate. Okay, and then we use grid search, and then we find like the next square the hippo should go to, and then the hippo will just move towards that position. Okay, so before we code anything, like let's just try to play the game and see whether it still works after the whole thing has been shifted. So yeah, it looks like it still works, and I can still collect. Yeah, so I just merely shifted the entire grid. Okay, yeah, looks like it works. Okay, so now for the scripting line. Okay, so let's take a look at the enemy itself. The enemy itself has okay, let's see what scripts have been created so far. So there's this script called enemy movement. So let's take a look at that script. Oh, okay. So this used to be the nav mesh 2D, which didn't work. So it has been taken out. So right now in the script itself, it is currently empty. Okay, so let's just do a simple move towards to just make sure that it kind of works. So new window, move towards Unity. So I'll be using move towards to move the hippo's position. So move towards just basically moves the vector towards a certain distance with a certain delta, which actually sort of defines the speed. So in the update section, okay, we can specify a move towards. So how you do this is here. Transform dot position equals to vector3 dot move towards this one. Okay, so we start with the position, and then we go to the target position. Okay, and what's the target position? Target position is basically uh, so we need to find the transform the of the player. Okay, so we just call this player. Okay, so player equals to find object of type. Okay, so under the player itself, we have like player action, player interaction. So maybe we just find player action dot transform. So we get the transform of that game object. So this finds a game object, and this takes the transform of it. So once we have this transform, we can then move towards the target position, and then the rate of movement, maybe we just set it as okay, why not we just make this a variable, so we just call it movement rates. Okay, so the movement rate will be configured. So we have public variables and private variables here. So the the movement rate will be a public variable, so public floats movement rates. Maybe we just set it as 1 first. Okay, so this should move the position of the hippo towards the target's position. So let's just try it. Okay, a simple move towards. This is really just the basics, just to make sure that it works. The name target does not exist in the, yeah, because this is supposed to be player. Okay, so this is a simple script to just move towards the player. Okay, so we're doing stuff like sort of incrementally here. Yeah, I mean, if you have any questions, you can just ask on the chat. But let's see whether the hippo moves towards the player or not with this script. Okay, so it looks like it's not really changing the position. Okay, so okay, this means that the player dot position. Okay, let's just print out. Yeah, we just print. Just want to see whether we have the player transform already obtained. Okay, if not, the hippo will not be moving. Oh, I know why. We haven't added in the script yet to this hippo. There's no enemy movement script here, so my bad. Yeah, I thought it was already added in, but it's not. So if we play here, I suppose the hippo should move to the player. Oh, okay. Yeah, it did move. As you can see that kind of move pretty fast. Yeah, it's like on the first time it's 1. This is the transform. It moved to 0.2, 0.3, 0.5. It moved a little too fast. Yeah. So maybe a 0.01. Yeah, I mean, we can configure this later, but as of now, we just want to make sure that the hippo can move first. This is step 1 of implementing the AI for this. So we make the movement to be 0.01. Okay, let's take a look whether it can work. All right, so right now we have the hippo. It should slowly move. I think this is good. You can see that the hippo is moving. Okay, the hippo is currently able to pass through the obstacles right now, because move towards doesn't really care about the physics. It just moves to the player. Okay, so we're just gonna make this slightly better. Okay, actually looks pretty creepy, isn't it? Yeah, so now you can see that the hippo is moving to the player, no doubt. Slowly but surely is coming to the player. Let's just kill ourselves. Okay, done. All right. So you can see that now we have a hippo moving. Okay, but the hippo is moving in ways that we don't want it to move. Okay, it's currently able to move diagonally. Okay, which is not something that we want. Okay, we want the hippo to only be able to move upwards, up, down, left, right. Okay, so let's just do a very simple, like a simple rule-based decision for our hippo. Okay, so we have the grid. Okay, so maybe in the public float, okay, x min, x max. Okay, actually this should be 15, right? If I remember correctly. If we look at the x itself, yeah, the grid so far it spans from 0 to 15. So 15 is the max position all the way on the right here. Yeah, so this is 15. And then for the y-axis is 0 to 6. So 6 is at the top here. Okay, so we want to like specify the grid position in the movement code itself. So we do x min, x max, y min. Okay, y min, y max. Okay, so simple. So if transform dot position dot x. Okay, if let's say the position itself. Okay, so I'm just going to do the very simple version of this script first. We move the hippo. Let's just standardize. We move it towards the 0 position. And then after that, we move it to the player's x coordinate. And then after that, we move it to the player's y coordinate. So the hippo will move in a very, very, very simplistic way. Just move from the x coordinate to the y coordinate. And after that, move to the player. Okay. So this is like roughly how we'll do it. So if the transform dot position dot x, okay, is equals to the player's position. So okay, so unfortunately, this player position, there could be many ways of the player, because this is a float. You see, so the player could be somewhere like um, actually we should match the x of the player. So the player could be like 1.4, 1.3, 1.2. Okay, but regardless of whether the player is at 1.3, 1.4, 1.5. Okay, so what we'll do is we will round it down. Okay, we'll round it down to the nearest, okay, to the nearest decimal. So there's this function mathf.round. Okay, so this will round to the nearest integer. So if it's a 0.5, okay, it will return like one of which even is written. Okay, so this round returns the even number. Okay, I mean it doesn't really round up for 0.5. So this is 10, this is 10. Okay, and then 11.5 will give you 12. So it rounds to the even number, but it's fine because it rounds down. Okay, so let's, okay, so what we do is transform dot position dot x. We want the hippo to always take the central position in the square regardless of where the player is. So we just do this mathf dot round. If the hippo's x position is the same as the player's x position, okay, then we can proceed to, okay, actually why not we just do the not equals first. Okay, so we do a very simple code. Okay, so the first move to player's x position. Okay, then move to player's y position. Okay, so how do we do this? We can just do a new vector tree. Player dot position dot x transform. Okay, this is a little weird, but this like separates the x and y. So player, and then the z can be like transform dot position dot z. Yeah, we don't really care about the z axis. So this just moves towards the player's x, and then we maintain the y position. Okay, if not, we move to the player's. So this just moves to the player's x, then move to the player's y position. It is just a, we just code this first just to see, you know, how this looks like. So this will go horizontally first, then vertically for the hippo's movement. So this one we keep the x position, and then we go to the player's y position. Okay, so remember, if the x position is not the same, okay, we actually want it to go to the we want it to go down. Okay, but okay, let's just play this and see whether it works first. Okay, so if let's say we don't want to do a star search and we want to do a very simple game I would say that this is like probably the easiest. Just let the hippo go to the like bottom of the screen, and then go towards the player's x position. And then after the hippo finds the player's x position, then it goes to the y position. So you can see that. Okay, maybe just for this, let's just make the camera for, let's just make the camera for the player. Let me just make the camera. Okay, the camera is projection. Okay, let's just make the camera bigger so that we can see the entire thing. Okay, just for this the purpose of this AI. Later we make the camera go back to the narrow position. So yes, the hippo is going to the X position first, then the Y position. So you see, if the player moves away, the hippo will translate to the X position first. Okay, and then after that it goes to the Y. Oh, it's not going to the player's Y position. Why? Yeah, that's interesting. Okay, so it's only moving the X position though. It's not going to the Y position somehow. Okay, so it means that the code for the Y position is bugged. Okay, so okay, so we go to the players. Aha, I know why. We need to do a rounding here. If not, if not, this will always be run because if we go to the player's X position, the player's X position is not rounded off. Then the hippo will be stuck there. The hippo will be stuck at a position where X equals to 1.45 or something like that, and then it will never move to this code here. Okay, so let's just run this code. Now it should go to the X position first, then it goes to the Y position. Later then we do the pathfinding. Let's just try the normal way of like just going X then Y just to make sure that it works first. I like to do incremental steps. So you can see that, yeah. Okay, so there's a slight issue with this kind of code is that if we were to just shift the X position straight away, you will realize that the hippo will not go into a rounded position first, then move. It will just basically X first, then Y. Okay, so it doesn't exactly avoid the collision here. Okay, but it doesn't really matter. Okay, so yeah, it looks like X first and Y is sort of working. Okay, so um, what could be done over here is that, okay, we want the player, the hippo, to always move towards. Uh, we want the hippo to always move in whole numbers. So, okay, this just shows the issue. Later, if we do the pathfinding, we want the hippo to go to a entire square itself. So, if let's say the hippo is at currently the grid position 0, 0, and then if we want to make the hippo go to position 0, 1, okay, we want the transition of this transform of this move towards to complete the transition from 0, 0 to 0, 1 first. Okay, before before we even change anything else. So basically, we want one single action to basically result in a whole number for the grid position. So for that, we need to create a private variable called um, has move. Okay, so we put this to be true at the beginning. Okay, so if have move has move. Okay, if so, basically we want to also have a, okay, we want to store this in we want to store the next position X and Y. So I'm just thinking C sharp got any tuple tuple where we can just store both of them together, like a tuple in C sharp like this. A tuple provides, yeah, so it's something like this. Double int t equals. Oh, I didn't know you could do this. This is something new. Yeah, so because we want to do x y, so I wonder if we could do a pair also. Because in C++, we do have a standard pair where you can like store two numbers. Okay, if not, we could just store the x in one variable and y in another variable. Systems collections generate key value pair, or use it, or this he created his own class, his own pair class. Because in C# you can do this thing called pair. Okay, looks like there's no pair in C#, unlike C++. That's fine. We can just do with tuples. Yeah, we could just do this. T equals to. Oh wow, you could do this. Interesting. Oh, you could do this already. Wow, it really looks like Python, the latest version of C#. C# 7.0. But let's not do with this because if you look in Unity, if you look with Unity, the .NET version is not that updated. If you go to file build settings, okay, in the file build settings, okay, you realize that um, in the, let's just say, player settings, okay, if you go to like build settings for the player, and then you just take a look at the um, see other settings. There's a .NET version somewhere inside. Let's just try to find a .NET version. I think it's under resolution. Hmm. Yeah, there should be a .NET version somewhere. There we go. So the API compatibility level for Unity, unfortunately, is only until .NET 4.x. Okay, means the C# 7.0 will probably not be supported. Yeah, so this is really cool. Yeah, I find that all programming languages should be like Python. And if it could be like Python and have C++ speed, I will use that language all the time. Yeah, right now what I'm doing is I use Python for deep learning. I use C# for game coding. I use C++ for competitive programming because all of them are used differently. I mean, Unity doesn't support Python directly as of now. I mean, you need to have some form of like add-ons. Okay, but anyway, what this shows is that we probably have to code the um, okay, so the X pos and Y pos we have to code it in here. Okay, so if okay has move is true. Okay, if not has move, okay, means has move. Okay, so if okay, let's not call it has move. Let's call it still moving. Okay, if it's still moving, complete the movement first if the hippo is still moving. Because as what I said earlier, we want to make sure that the hippo is within the 1 by 1 square. Okay, so that when we actually move, the hippo will move to an integer coordinate, integer x and y coordinate before moving to its next action, and hence avoid stuff like going in between the obstacle. Because later on we'll be moving the hippo by grid square motions. So if the hippo is still moving, okay, then very simple, we can just do this. So transform dot position. So let's create because we'll be doing the movement thing quite a lot. Let's just create uh, a void move. Okay, and then this will take in an integer y, integer x, integer y. Okay, and then this one will just basically transform dot position equals to vector 3 dot move towards. Okay, so okay, then here will be new vector 3 x y, and then transform dot position dot z. Okay, and then we have movement rates. Okay, so if you see that you use this transform move towards code many times, okay, we could just have our inbuilt function here. So this one would be an inbuilt function to move to a certain x and y coordinate. So this is refactoring your code. So that's if it's still moving, okay, we just need to move to the previous x and previous y. Okay, so the previous x and previous y, okay, very simple. So we could just at the beginning we just make the x pos and y pos to be the current position of the where the hippo is. Yeah. Okay, so this one will be the starting x pos and y pos. Okay, on the update, if still moving is if the hippo is still moving, then move. Okay, and then if okay check if the hippo has reached its position, its destination. So it's like going from cell to cell. If x pos equals to transform dot position dot x and y pos. Unfortunately, we cannot use like tuples to check this. So we have to check one by one. Yeah, we do it the hard way, but isn't that hard actually? There's only two variables. If it has reached its destination, then what we do is we just make still moving equals to true equals to false. So if still moving is if it's not still moving, then choose the next position. If the hippo is not moving to a destination, choose the next destination. So over here, let's just delete away all this code. Okay, so that was just exploring. What we will do is we want to make the hippo move towards the um, position of the. We want to make the hippo two simple rules for this. Okay, later we'll use a star search to do the destination searching. So our very simple search is move towards the player's X position first, then move towards the player's Y position. So we can just check if okay transform dot position dot x equals to player, because player is our target, player dot position, and then we need to like sort of round it. Okay, so if it's not equals to, then what we do is we'll do still moving equals to false equals to true. Okay, we want to set the ball rolling. We want to let the hippo move. So the x pos equals to this, equals to the player's x pos, and the y pos will be equals to the current hippo's y position. So this one will be move towards the player's x position first. Okay, else okay if okay, so if let's say the y and the x position are all the same, right, we don't have to do anything. So if the transform position is the same as the y, not the same as the y, okay, then what we need to do is we need to do this same thing also. We need to make sure that in this case we want to go to the y pos is the player's y position, and the x pos is just remaining to be the x position, and then we set still moving to be true, which will then call the movement update. Okay, which will then call the movement update on the next frame. Okay, so I've typed a chunk of code. Okay, this just to simply move the hippo on the x-axis first, then move the hippo on the y-axis. And so now let's just see whether this kind of works. Okay, there's quite a number of errors. So cannot implicitly convert float to an integer. Line 21. Oh, okay, I see. Okay, so you just call this float. No issue, because the round, after you do math f dot round, apparently it returns a float rounded to the nearest integer. I'm not sure why it returns a float, because if you round it off, it should be an integer, right? But since they make it a float, we are not going to argue too much with it. We're just going to use a float instead. Cannot convert float to integer. Line 36. Line 36 is here. Move. Okay, so in my move function, I have two inputs which are floats. It's okay. We just make the input become. Sorry, the two inputs are integer, but in order to be compatible, we just make the two inputs be a float. So this should be how it goes. Okay. So actually, we don't really need a star search for this. Actually, this simple go X first, then go Y first is already kind of optimal. We just need to avoid the trees. Okay, we just need to make sure that the hippo doesn't touch the tree. So if the hippo reaches the tree, we just need to reroute it. So now you see, if the player moves, okay. Oh, Wow. Okay. It's supposed to aim the X position first. Okay, so there's a slight issue here. It must go all the way to the player's X position, uh, all the way to the previous player's X position, or all the way to the player's Y position. So it like goes redundant steps. What we really want to do is for the X position and the Y position to be just like one more from the existing one. So one more from the existing current position. So what we can do is like this. Okay, if okay, if the transform dot position, or rather if this thing here, okay, we're doing this operation quite a few times, we can consider making this like a separate variable. So let's just do this. So that we just run it one time. I mean, it wouldn't save much because it's not very intensive actually. But since we are doing this so much, we might as well just, just have a separate variable for it. So if player X greater than, okay, so actually we could do something very cool here. So what we could do is we could do xpos equals to xpos plus, okay, and then we could do this cool thing here. Uh, we check whether the player X is greater than transform dot position dot X. If it is, then we add one. If not, we add minus one. Yeah, and this is a cool way to just say that you just add one more or minus one based on whether the player is if your player is to the right, then we add the X pause by one. If the player is to your left, then we add the they subtract by one. I mean, you can also do an if else loop for this. So this we do y pos equals to y pos player y greater than transform dot position dot y. Same thing here. Okay, so we only move, like, let's say the hippo is 0, 0 and the player is at 0, 5. We want the hippo to move to 0, 1 first before we do anything else. Okay, so this is how we do it. Okay, and as what I said earlier, we could change this to be player y. Okay, because we already set our two floats to be the rounded position of the player. Okay, okay, so this is a very simplistic version of the code. Just move to the X position, then move to the Y position of the player. Okay, let's brave the errors. Invalid term. I think I might have missed out close bracket somewhere. Okay, I have one extra close bracket over here. So let's see, operator plus cannot be applied to book floats and bool. Ah, so maybe this whole thing needs to be in a bracket. If I want, it is called the ternary operator, where you do if this condition is true, then we load this one. If not, we load this. So let's just I don't know if this will work. Ternary operators in C sharp, but if it doesn't, then we're just gonna do the old school if else loop. If not, the ternary operators are always cool. I love them. Unfortunately, Python doesn't have them. That's why in Clash of Code, I've been not exactly very like optimal. Okay, so now you can see that goes to the x-axis first, then the y-axis. So even if I shift my player, okay, let's say my player was initially here, then the moment I go past the hippo should straight away go to the player already. So this means that the code is implemented correctly. Okay, so now of course you can see that it passes through the obstacles. We have to have a way to code for that. Yeah, so actually you can see over here, it is indeed quite optimal already. Okay, I mean, assuming that, let's say if we reach an obstacle, the hippo needs to be coded to do something else. So right now you can see that the hippo goes to the x-axis, the player moves, the hippo will follow. If it's the same x-axis, the hippo will go to the y, but it prioritizes going the x first. Yeah. So far this is all right. It's working as expected. Okay, very good. So yeah, that was a simple way of getting the next position. Okay, so now let's say we want to code in the we want to code in where the like what do you call that? Okay, we want to code in to see whether like all of the what are the possible like okay, let's think about it first. Now I want to do a star search. Okay, so let's see. I just write here. So A star search as procedure is as follows. Okay, so A star search is like that. First, start with empty queue. Okay, add in a hippo position as initial node in queue. Okay, pop first element in queue. After that, add in neighbors of element which is not in visited set. Okay, add neighbors. Okay, so maybe what we do is add neighbors into visited set. So there's a list of stuff that we need to do for this. So we do have to maintain a list. Maybe we just call it a list, not a set. Add the neighbors into the visited list. Add neighbors of element which are accessible into visited list, into queue and visited list. Yeah. Which are accessible and not invisible not in visited list into queue. Add in. Okay, let's see. Okay, be quite simple as like if we could do the visited list in here. So if element in visited list return rather pop next element. Add elements in. Okay, so over here the queue. Okay, it should be a priority queue. Okay, and the priority queue should be based on the. It should be based on the. This queue will be based on the current cost to node plus estimated future costs. Okay, so this will be a star search. Okay, but actually, what we could do is really just do a okay. Maybe instead of doing a star search, okay, we could just do a simple breadth search for this game. I mean, to be honest, I don't think it will make too much of a difference. The breadth search is way easier. Breadth search is you just basically just pop first. You don't even need a priority queue. You just pop the first element in the queue. Okay, and then after that you add in the neighbors into the queue which are accessible and not in visited list. Okay, actually why not we just make it which are not in visited list into queue. Okay, so at the beginning add inaccessible positions into visited list. Okay, let's just do we just do a BFS first. Okay, A star search is just an extension of BFS, breadth first search. It's breadth first search. Yeah. So you start with empty queue, add inaccessible positions into visited list. Okay. Add in hippo position as initial node, pop first node in queue. If node in visited list, okay, skip. Add in neighbors of element into queue. Yeah, so I can either restrict the queue here or I can restrict the queue at the top. So I'm still thinking whether or not like we should do like a check here to just prevent like more neighbors to be. Mm, actually, we could do both. Yeah, actually, it doesn't really matter because if we do a check here, or if we do a check here, the runtime will still be the same actually because we still need to incur like on time to search the visited list to check whether the node is there. So that is still going to incur some runtime. Yeah, so I think it's not that crucial actually. Okay, add in neighbors of element into queue if not in visited list. Okay, and then after that, add in neighbors of element into visited list. Okay, and then after that, if the actually I think this one we don't need this. Yeah, because if we add in this and then we update the visited list, then this part here, if no in visited list skip, we won't need this anymore because we would check down here already. So at pop as a hippo in initial position, initial node in queue, pop the first node in queue. Okay, if node is end position, break. Okay, so here we will need to take into account. Okay, in for each node that we add into the queue, we need to take into account of what was the like for each node we need to basically store the parent. Okay, or maybe not the parent, we can just store the position to move to. So we could just store either up, down, left, right. So we will need a struct called node, and then this struct will contains the x and y position, and okay, contains x y position, and also this contains the um, okay, so there's quite a few things that we need to do here. So the structure of this node, we contain the x and y position. We also need to contain the parents. I'm still thinking whether I want to use the parent method. Okay, because actually all we need to do is we don't really need the entire path, you see. Right? All we really need here is just where to move in the first position. So, we could just have a direction variable. So this direction variable is just 0, 1, 2, 3, which will indicate whether is it I can just write it here, up, right, down, left. Yeah, so this will basically just be, maybe 0 will be undefined, then 1 will be up, 2 will be right, 3 will be down, 4 will be left. So it will start off as undefined for the direction. Okay, and then it will then so basically based on the neighbors of the element that we add into this set, okay, we could then set the neighbors. Actually, we don't really need a struct for this. I can think of a way easier method to do this. So set the neighbors direction variable. So if the node is in end position, break and get the direction variable in that node. So we don't really need this node also. So we can just store data in arrays. So we have an array for of size x times x limit times y limit, or rather we can just put like width times height, array of size width times height for the um, nodes. So this node will be a boolean array maybe. Yeah, this node will just be whether the node is visited or not. Okay, and then we also have a we also have a direction array. And this will contain the, I'm just like, what I'm doing now is I'm just like thinking of what I need to do for the code later. Yeah, so the bool array here, this will be is an int array. This is a bool array, okay, of size, width times height. Okay, and then this will basically just, yeah, so we just contain whether the the node position is visited. So node position is given by y times width plus x. Yeah, so basically we can just, hi Kashiko, I'm trying to do like a star search, but right now before I translate into a star search for the hippo, I'm actually like doing a breadth search first, because breadth search is much easier. Okay, we just make sure that it can work first. Then a star search is just an optimization of breadth search that just selects the node better. Okay, but I think for this game actually breadth search is good enough, because the issue about a star search is that you need to have a priority queue. So that will take O n log n time to add in the element. So I'm not too sure that the time saved for A star search is justifiable in this game, because you see in this game if you do breadth search, actually you can find your path quite easily. There's quite a lot of open areas. Okay, but either way, just do this breadth search first, and then like we see whether it works. Yeah, because honestly I never coded this yet. This is my first time coding it for Unity. Okay, I previously coded it maybe for C++. Okay, so I'm just trying to avoid. I was thinking of initially doing a structure for my notes, but I think actually we don't really need a struct for this. We can just use an array, because we only have x and y axis. We can use a clever manipulation of the y and x axis like this to get a node position. So a node position will be like 0 for this hippo, 1 for this square here, 2, 3, 4, 5 until 15. Then here at the top, this will be 16, 17, 18. Oh, sorry, this 0, 1, 2, 3, 4, 5 until 14, until 15. Yeah, until 15. Then here will be 16, 17, 18 until 32. Then here will be 33 and so on. So we can define each node by a number. Okay, instead of having two variables x and y, we can define a node position given by the y position times the width plus the x position. Okay, and then we have a bool of whether the node is visited. Yeah. Okay, so all these things well said. Let's just create first. So we need a boolean array of it of this quite is visited, and then this one will be given by actually 16 by 7, 16 times 7. And then we have another array called int, which will store my initial direction. Okay, so I'm not too sure how do I initialize an array in C#. So let's just Google it. Yeah, so if I want to initialize it to a certain value, okay, so let's see. If I want to initialize my array to a certain value, for value types, initialize with the default values. So it will be 0. For nullable types, s value is set to false. Yeah, it looks like I don't have to, Looks like I don't have to initialize it. And int array all initialized to 0. Default array is initialized to false. So it seems like I don't have to initialize it. I just need to declare the array, and then it will just initialize to the default type, which is great. Yeah. So, oops, wrong one. Here, yeah. So this tells us whether node is visited, and this tells us the initial direction of Hippo approach. So yeah, all this is kind of simple. Okay. So what we want to do now, I just want to see whether I can create a queue in C sharp. If not, I can use a list also. Yeah, queue. List is fine for this purpose because we just need to pop the first element. Yeah. Queue represents a first in, first out collection of objects. So this is in the systems.collections.generic. So we need to use this. And then we just need to enqueue this here. Enqueue this, enqueue this, enqueue, enqueue. Enqueue, I guess, is add to the back of the queue. And then you can dequeue it. So enqueue, I guess, is to add it in. And then where's my dequeue? Oh, you can have this dot contains. I didn't know you can do a dot contains in C sharp. Something new today that I learned. Yeah. I'm more familiar to do this in C++, to be honest. Yeah. But programming languages don't differ by much. Yeah, I just need to learn new functions in each of the languages. Yeah, so it looks like enqueue is to add into the back of the queue. And then like, I think there's a dequeue. There's a dequeue somewhere. Can you see they right line this one? Contents. Dequeue removes the oldest element from the start of the queue. The capacity is the number of elements that it can hold. As elements, capacity is automatically increased. Awesome. See, all languages should be like that. You automatically change the size. If you were to do this manually in C, you need to malloc twice the size the moment you exit. I mean, they do this internally, I guess. Yeah, once you hit the capacity of the queue, they will automatically allocate a memory size twice the size of this existing queue, then copy the elements one by one into the new queue. Yeah, I mean, that's what most like helper methods in C++ does anyway. When they have this standard libraries. So I suppose C sharp also has their own standard libraries that do this, that does this. So we could have clear, we could have, oh, this is not bad actually. This queue is not bad. I wonder if they have priority queue also. Priority queue in. I remember last time C sharp doesn't have priority queue, which is a pain. Yeah, it's a real pain. You have to like create your own priority queue. And now it looks like they, oh, this is .NET 6. It's queue in .NET 6. .NET 5. .NET 4. Okay, we need to make sure that it can work with .NET 4, okay, because Unity is using .NET 4. So we don't did I see something? We don't recommend you use the Q class for new development. Why? Why? We don't recommend. Then why do they even have this here in the first place? We don't recommend you use the Q class for new development. Instead, we recommend the generic Qt class. Okay, I mean, I'm gonna use this, so it's fine. Yeah. See, all languages are going to. Oh, this is the old Q. Okay, let me just search .NET 4 priority queue. I'm taking a bit of a detour here. I'm just exploring what data structures there are in C Sharp to make your life easier. If you use the right data structure, you save a lot of effort coding. Yeah, so data structures are kind of important also. Yeah. See, this is what I read before. I tried to search before for priority queue, and they tell me that there isn't. Yeah, see, it did not see value in right. So that means priority queue is a no-no. Okay, we cannot use priority queue because .NET version 4 doesn't have it. But it looks like queue is possible. Yeah. So there's a lot of tutorials to like teach you how to do priority queue. But honestly, actually, you just need a search at the beginning of the queue. I mean, priority queue is good because you do an O n log n search only when you insert in the queue. But if you don't have a priority queue, you just need an O n log n time to search the entire list or entire array and find the minimum element. Yeah, that will take O n log n times the number of iterations that you are searching for. So it's not that bad. It's not that bad, but I think priority queue is good. Yeah, priority queue. Okay, I'm just going to use this Qt class. Okay, I never used it before. Okay, but it looks pretty simple. Yeah, using systems.collections.generic is already there. See, it's already there. So okay, so over here is move towards the player's X position, move towards the player's Y position. Okay, it doesn't matter anymore. Okay, we are not going to use this anymore. Okay, we are going to use the, let's just call it BFS. Okay, and then we have BFS. Okay, we have the current position and that. So okay, so very simple. We have a void BFS here. This one will be a float nx, float ny. Okay. Okay, so we will need a queue. So now we have this queue int node equals to new queue. Node. Yeah, let's just call it node. Yeah. So this we have a new queue. We can also do the queue here and then we clear it over here. But I think it's okay to just do a new queue every time we run this function because C sharp when you exit the function it will just destroy the memory allocation for all the values that you created or all the variables that you created. Okay, automatic garbage collection. Unless you define a global variable at top here, then it won't destroy. But if we have a variable defined in the class here, after we exit this, sorry, define this function, after we exit this function, this queue will be destroyed. Yeah. So I think this is fine. And then we have node.enqueue transform.position. Okay, so what we need to do is, okay, let's just make both of them an integer. So we have an int because I want to do the q as an integer, you see. So we want to make the integer because over here the array index is an integer, so I might as well make the stuff here as an integer already. So we run the breadth search here. Okay, the breadth search should return, okay, it should return two parameters actually. It should return the x and y position of where the player should go. Okay, so unfortunately in C sharp you it's not like Python, you cannot return multiple variables in function in C sharp. So uh, you could return an array. That's one way to bypass this. Okay, you could return an object, return a two. Okay, so let's see if you want to return more than one variable. Okay, yeah, you could have a out integer max here that stores one variable and you return another one. That's one way to do it. Uh, in fact, that may be a good way to do it. Let's just do it that way. Yeah. So we have two out variables here. Oh, actually, we don't. I realized something. We don't need this. Yeah, we just need direction. Yeah, we don't have to return multiple variables. We just need to return what direction that we should go into because this direction itself is the main thing. Okay, so I realized also that this is visited at this direction. Okay, we should actually declare here. If not, we have to every time when we run the breadth search, Okay, every time we run the breakfast search, we need to initialize it and make it all zeros or make it all null. But if we do it here, they can actually do it for us. So I think the code complexity is the same. So we might as well just do it. The runtime is the same. So we might as well just do it in this function BFS. So we have a direction here, right? So let's have an direction equals to this. Okay, if direction, okay, so there are four outcomes. So if direction is 1, if direction is 2, if direction is 3, direction is 4. Okay, if direction is 0, we are not going to do anything. Okay, it means that we have reached the position. Okay, so basically like this, if direction is 0, return. Okay, we're not going to do anything else for this. Okay, that means it means we're not going to do anything else. Okay, if not, if this direction is 1, 2, 3, 4, okay, we can just encompass them in the else loop. Okay, and then we just make still moving equals to true. Okay, still moving equals to true just means that we want to set the movement of the to the player. So over here, based on the direction itself. Okay, so if direction is 1, I guess we're just going to do it one by one. Yeah, direction is 1, x pause. Okay, let's just do some comments. Remember what I mentioned below here. If it's 1, it's up. So 1 is up. This is right. This is down. And this is left. Okay, actually it would be easier if we could just, like do a sort of a dictionary mapping where you map a direction to a tuple, like 0, 1, 1, 0, minus 1, 0, 0, minus 1. Then you can just add those tuples to the current transform position. Okay, but it's not that intuitive to create like this kind of dictionary tuples in C sharp. So we're just going to do it the longer way. Yeah, C sharp is not as code efficient as Python. Yeah. So if it's up, okay. So actually what we can do is we can do this x pos equals to transform dot position dot x, y pos equals to transform dot position dot y. Okay, so by default all this is already done, and then we can even make the still moving is true at the top here. So based on the up, down, left, right, we just change the x pos or y pos accordingly. So if direction is 1, it means we change our y pos, right? So x pos equals to actually we can just even do this x plus plus plus. Move up, right? Oh, sorry, move up is y plus plus plus. Oh yeah, this is great. If we move right, it'll be x plus plus plus. We move down, then it'll be y plus minus minus, and if we move left, it'll be x plus minus minus. Done. Yeah, done. So this is, if you want to do like breakfast search for the hippo movement, you can just do like this. Okay, based on the direction, and then the direction will be the return value of this breakfast search. Okay, if we do A star search, then this one will be called A star search. Okay, but for now, I think breakfast search is easy. It's easy, and honestly, we don't really need A star for this game. So it's okay, we can just do breakfast search. Yeah. So when we do breakfast search, we have the end goal in mind. Okay. In fact, actually, this angle we don't really need to do it like this also, because we could do it the very same way that we do for the rest of the node. We could do it like that times width. Okay. So what is this width? So this width is actually the same as y max, sorry, x max plus 1. Yeah, we could do this. So over here, this one will be int and node. Okay, so now we need to enqueue. Okay, we need to enqueue all the. Okay, so the queue here is an integer. So let's see. Let's just put this entire breakfast search here. Okay, then we just okay, so this was my thought process just now. I'm just gonna put it here. Store data in array. Okay. Node position is given by this. Okay. Bool size of this. Okay, then we just let's put this bool here. We don't need this anymore because the description is at the top. At the top, then we have the initial direction here. Okay, then we will have a queue, the main D, order of expanding nodes. So this one will be here. Q integer node equals to this. Okay, node dot enqueue. We want to enqueue the current node, so we will take the transform. So maybe we have a current node here also. Yeah. So in order to get the current node, we can have the integer. Okay. In fact, we don't really need the round. I realize if we do a typecast integer, it's sort of rounded to an integer already. So integer transform dot position dot x integer plus transform dot position dot y times max plus one, comma this one. So this one will be the current position and this one will be the end position. Okay, as easy as that. Okay, so current node and end node. So we enqueue the current node. Okay, first start with empty queue, add inaccessible positions into visited list. Okay, while queue is not empty, or while queue is not empty. Okay, so at the end of it, we will just return 0. If let's say we cannot find a suitable position, we just return 0. So while queue is not empty, well, okay, how do we know what is empty? Queue.count, I guess. Yeah, the queue.count will give me the number of elements in the queue. Yeah, so normally this should do it. If the variable is greater than 0, then it will be positive. But just to be safe, we just do it like that. Yeah, because some languages, the negative is considered true, so only 0 is not empty. Yeah, but actually this should be fine because as long as it reaches 0, then it will be false. But just to be safe, we just do this. While the queue is not empty. Okay, then we do this whole thing here. Okay, so okay, we should do this. Okay, I think it's more or less done. First start with MTQ. I commented quite a lot of my code, okay, because it's easier. It's easier to easier to program if you have. Oh no! What did I do? Oh, I think I deleted it. It's okay. It should be safe, right? Yeah. So I do have quite a lot of comments over here, commented code, which would probably help in terms of the coding of this. Okay, so now I do have quite a few things that I want to code. Okay, I like to pop the first node in. So we'll just code this in this order, one by one down there. Pop first node in queue. Okay, so let's see, how do I pop the? So I guess it's DQ, right? Removes and return the object at the beginning. Okay. pop the first node in queue. So I guess the queue will give me an element, right? Returns the type. Yeah. So maybe I'll just call it integer current. Okay, this shouldn't be current node anymore. This should be start node. Okay. Here integer current node equals to node dot dequeue. Guess that's all right. Dequeuing one dot dequeue. Yeah. This is exactly how we do a dequeue. Okay. If node is end position, break and get direction, break and return. Actually, we don't need break and get direction. We just return the direction variable. So just return the direction variable in that node. So if current node equals to end node, okay, then return direction off. Yeah, so as you can see over here, my direction variable is here. Okay, add in neighbors of element into queue if not visited list. Okay, so this adding inaccessible positions later than we do it. Okay, we just put as a to do first. Okay, but basically it's not add, actually it's more like set inaccessible positions as visited in visited list. So it means that when we look at all these like little trees here, we need to set them as visited so that the array will not go into them. Okay, so we do have this enqueue the start node. Okay, pop the node in queue. If node is end position, return that direction variable. So I mean there are a few ways to get direction. One is if you need the entire path, you can then actually what you do is you can then create like a parent node. So instead of direction, you can have a parent. So for each node, you can store its parent, and then you can do backtracking all the way until the initial node. Then you can take the initial node's number and the parent's number, and then you can do a calculation to see what direction is. But here, just to make things simple, because we just need to know what direction the hippo needs to go next, we could just store the direction variable, and then as we expand the nodes, okay, we just make the next few nodes take on the same direction variable as the first node. So in some sense, we already sort of do the backtracking all the way while we do this algorithm without really needing to do backtracking at the end. So that's the beauty of it. We could just return the direction like that. Okay, it's actually direction like that. Add in neighbors of element into queue if not in visited list. Okay, so if is visited. Okay, so we want to add the neighbors of the elements. Okay, so what are the neighbors? So the neighbors of the element, okay, they are namely, okay, they are namely these few elements. So you need to move up. Up means plus x max. Plus x max plus one. Okay, down it means minus x max minus x max plus one. Because we name the node based on the width here. This width is x max plus one. So x max is 15, plus one is 16. So there are 16 little squares here on this horizontal. So if we label this node as 0, 1, 2, 3 until 16, next 0, 1, 2, 3 until 15, next node here will be 16, then here will be 32, then 60, 32, 48, 64, and so on. So, we already have all this position. We can just plus and minus. Okay, if it's left and right, okay, left and right is tricky, okay, because we may actually be like somewhere here, node number 16. Sorry, this is node number 15, and then you move right, it goes to node 16. But you can't teleport from here to here. Yeah, so maybe okay, we cannot really do this anymore. Okay, so we just add the neighbors one by we need to decompose our node into its corresponding x and y axis, which is actually pretty simple. If you ask me, this is to do some tricks here. So you see your current node here. So we have an integer x pos and y pos, and we can call it x pos y pos because if we have it in a function, this will take priority, but we don't have to do it. We can just call it current x and current y. So current x, okay, current x is just the modulo of the number percent of the number divided by x max plus 1. So it's equals to current node modulo x max plus 1. Okay, and current y is equals to the integer of the, okay, current node divided by x max plus 1. So it will take, because integer will always round down. So this is actually a flaw. Yeah, I mean if you really want to be safe, we can also do this mathf.flaw and then we can do this here. But I'm pretty sure integer is round down. Okay. Yeah, I mean we can check this. Is C# integer rounded down? Okay, looks like we need to do a, yeah, this will truncate the number. Yeah, so an integer is good enough if you ask me. I mean, if there's any problems later we can change it. So we do need to segregate it into like this. Okay, and then basically we will check whether we can reach there. So this is actually an adjacency matrix, which is easily coded here because it's just either up, down, left, right. So if current x greater than 0, okay, we do up first. Okay, up, down, left, right. Actually, we just do up, right, down, left. I mean, this is in order of our, it's in order of this up, right, down, left. We can do up, right, down, left. Yeah. So up, right, down, left. What we can do is if the current x is smaller than x max, then we can do up. Okay, then we do it. So these are the conditions necessary for us to do this. So x min. So if right is if it's current y. Oh, I got it wrong. This will be current y smaller than y max. If right is, it will be current x smaller than x max, because we want to make sure that this is not all the way at the edge of the map. Then down will be current y greater than y min. Then we do whatever's here. And then if current y smaller than y max. Wait, wrong. Current x smaller, greater than x min. We do here. Okay, so all this over here, if set the neighbor's direction variable and add. Okay, so we just put here. Okay, so let me just enqueue it here. So let me do the enqueue first. Node.enqueue. Okay, node.enqueue current x plus current y times x max plus 1. Yeah, so we enqueue this. Okay, so each one will be different. Up means our current y will need to plus 1. Actually, it would be easier if I were to have a variable called. We just have a variable called next. Yeah, so I can just, yeah, let's just do this next x and next y so I don't have to code so much. Next x, Okay, so we can enqueue this. So in the up, okay, in the up method, we can actually change the next y. Okay, we can just next y equals to mm, there's a slight issue here, because if I were to do it like that, my next y would be edited in my first code already. So yeah, maybe let's not do this. Just do by current x and current y. Yeah, it's neater that way. Yeah. Sorry that you are having to see this multiple times. Yeah, we just go back to current x and current y. Okay, and then for up, what we do is we just take current y plus one. So this is the condition to ensure that it's not at the edge. Okay. So also we need to check that that is not in the is visited list. So is visited. So so if this is up, then okay, I got an idea. Up node, right node. We can just call like okay. So this will be down node. Maybe down node will be minus one. Okay, right node equals to yeah. So we can like already have the node values here, and then we have a left node will be equals to this. Okay, and then basically we can just check whether or not this one will be up node and not is visited up node. And we can then put this up node into the queue, and then we can just change the is visited up node true. Yeah. So we can just do this for every single one. So we add the node into the queue, and then we just set it to the visited to be true. So this one will be right node, and queue the right node, and queue the down node, and queue the left node. Okay, and each of them we just need to check whether just make sure that it's not visited already. So if it's an obstacle, this will mean that it should already have been visited, and then it will not be added into the search. Okay, so that's what we do for up, down, left, right over here. This is just a way to do it. Let's see. At, at neighbors. Okay, so we need to set the direction, the neighbors direction value as well. So this is good to have some pseudocode before we start coding, so we can remember what we need to do. So we need to set the neighbor's direction variable. Okay, how do we set the neighbor's direction variable? Okay, see, we have initially this variable here of direction. Okay, so if the current okay, let's just put it at the back. If direction of the current node, okay, so I need to have a current node here. If direction of the current node, okay, is 0. If direction of current node not equals, or actually if it's greater than 0, then we just carry on. Okay, direction of up node equals to change set direction of next node. Actually no, I don't need to put this. So add into queue, add in neighbors of their element to visit list, and then So number one, number two, and number three. So these three steps will be done for up, down, left, right. Yeah, there's a lot of duplicate here. I mean, it would be good if we could like do a for loop, and then in each for loop we run through this array which stores the next node position. Yeah, but then we need to take into account this condition here. So I guess there's no escaping from it. We have to do like a hard coded up, down, left, right here. There's no escape here. So yeah, if the direction is greater than 0, then we take on the previous direction. If not, the direction will be, can you all guess what will the direction be? Okay, the direction will actually just be up. So up in this case, remember what we said, up is 1, right is 2, 3 is down, 4 is left. So the direction will be up. Okay, then we can just, copy and paste this thing here. Let's copy and paste like that. Like that. Okay, direction of right node will be direction of current node. Else direction of right node will be 2. And then this one will be 3. This direction of down node. And then this direction of left node. Hi, this is breakfast search. You're right. Yeah, I'm just doing breakfast search first. Okay, the A star search actually is you need to do additional steps. Okay, the A star search, instead of popping the first node here, you need to find the minimum value. Yeah, this is a breakfast search. You're right. Yeah, I actually want to do A star search, but I come to realize that C sharp .NET 4.0 doesn't have priority queue. So yes, you're right. We could store it in a heap, and then after that we could just take the stuff out from the bottom of the heap. Yeah. So if we were to do an A star search inside the enqueue, if we could do a priority queue, yeah, C sharp doesn't have priority queue. Only .NET 7.0 has it. Yeah, but if you have a priority queue, it's actually very easy. You just need to push the node in with the corresponding cost to the current node plus the potential future cost, which is estimated by a Manhattan distance to the endpoint. Yeah, but I'm thinking if breakfast search can work quite well, I don't really need A star search. Yeah. But yeah, so now I've coded in all of them, and then what this will do is to return the direction, and then once we get the direction, we will then be able to tell the hippo what is the next square that we want it to move to, and then after we tell it what's the next square to move to, the next time step, okay, if it's still moving, it will move to that position. Once it has moved to the target position, you update the still moving to false, and that's what it will do. So breakfast search. Okay, I think I've done most of it already. Let's brace for errors. I knew it. I knew there's going to be errors. That array declarator. You declare manage array. The rank precedes the variables identifier. Okay, that was 86. I have a feeling it's because we have to do something like this. Yeah. I mean, if you want to do like an array of size, we need to manage ourselves. New ints. Oh, that cleared so many errors. Okay. Line number 141. Line number 141. If current x greater than not is oh, I forgot the n. Oh, now there's more. Okay. Cannot convert from float to int. Now line 62. Cannot convert from float to int. Okay, I'm going to try something. Just gonna make this whole thing int like that, and int like that. Okay, yep. I'm gonna try something, see whether it works. Cannot convert from void to int 962. Is there a void somewhere in this code? Mm, okay, it seems like there's some issue with this. I wonder if I can just do an int function like that. Like instead of doing a typecast, I can just bracket int. Oh, I can. Oh, invalid int. Okay. Um, I can't typecast like that. Yeah, I wonder if I can just do it on separate. I mean, if there's some issues with doing all at the same line, let me just split it up, and then just do something like that. Yeah. Yes. Oh yes. Thank you so much for your help, Stephen. Are you Minhyun? Yeah, I think you are Minhyun. Yeah. Thanks so much. Yeah. It does return. Okay. 962. Something expected at 962. So this thing here. This one. I think I have an extra close bracket. Yeah. All right. Look at that. Cannot implicitly convert from float to int. Are you missing a cast? Is this not enough? Is this casting not enough? X max is an int, right? It's a float. You know what? Let's just make this a float. Yeah. And I just typecast it here. Aha, that settled it. Cannot convert systems.collections.queue to systemscollection.generic_queue. So this is line number 91. I think I need to do this. Yep, that does it. Cannot implicitly convert from float to integer. An explicit conversion exists. Are you missing a cast? I guess I am. Yeah, I guess I'm missing a cast, a typecast. Are you missing a cast? Yeah. 9110. I guess I'll typecast everything. Yeah. 911028. All of these have problems. All of them say that I'm missing a typecast. So this is proving to be a little irritating. Yeah, because I do have a typecast already. I'm not sure what else they want from me. Yeah, I don't know. I mean, I thought this was really good enough. Okay, finally I 112. Now it's 112. Cannot convert from float to ints. 112, 113. Where is my float? All these are ints already, right? All these are ints. Current Y's and ints. Oh, X max and X my are floats. Okay, let's just make this an int. Okay, yeah, let's just make the X max an int. All right, that solved quite a lot of problems. The name directory does not exist. Sorry, the name direction does not exist in the current context. Line 120 doesn't exist, isn't it here? Oh, I called it direction. Okay, since I like to call dir so much, let's use dir instead. Oh, yes, all clear. Okay, now to see whether it sorts of works. Yeah, help me. The hippo is coming. Okay, looks like okay, it's quite fast. It's quite fast. So it looks like the breakfast search is kind of working. You can see that the hippo is like it does its best. Look at that. Okay, let's just see whether it gets tricked into going somewhere else. Okay, yes. This hippo is on the run. This hippo is on the run. It's fast and furious. Okay, so I need to add in certain things into my visited sets. Okay, yeah. So it's because we haven't coded in the obstacles yet. So now what we need to do is for every single obstacle that you see over here, we need to find the x and y coordinate. So let's just use the hippo. I'm so happy that reference search works. Okay, so we just use the hippo. We try to find out where are all the obstacles. So you can see over here, 2, 14. Yeah, so this tree, the top and the bottom cannot be moved inside. Yeah, meaning the tree at the top, the player also cannot go through, right? So I have to block off the bottom and the top of the tree, right? Yeah. So 14, 1 and 14, 2. So now let's do the to do. So yeah, so we need to add in. So let's just add in. So the tree is 14, 1, 14, 2. Okay, let's go to 12. I mean, it'd be good if we could do this automatically. 12, 3, 4, 5. 3, 12, 4. That means whenever you change the map, we got to change this pathfinding accordingly. Yeah, which is not exactly the best way of doing it, but I guess another way that we could do this is we could, like, at the start of the game, we could set the hippo to like go through all the positions one by one, and then just see whether there's a collision there or not. We can update the inaccessible positions accordingly. I mean, that could be one way to do it. But as of now, let's just try to just update this hippo with just the 9234. How do you intend to do the auto? I'm quite interested. Yeah, I mean, because I think one way is at the start you do a for loop and then you make the hippo appear at one by one at all the positions, and then you just check whether there's a trigger or not. Or what we could do is, like, I don't know, is there a way to from the tile map find out where are the trees? And that would be good also if we could from the tile map do it. So 5, 5, 2, 3, 4. 2, 2, 3, 4, 5. Yeah. Okay. So we do need to have all these things inside the code. So maybe what I can do is I can do this integer. We can just have a obstacle x 14, 14, 12. I mean, this is a little manual. 14, 14, 12, 12, 12, 9, 9, 9, 5, 5, 5, 2, 2, 2. 1, 2, 3, 4, 5, 2, 3, 4, 2, 3, 4, 2, 3, 4, 5. I mean, to do like that. Or we could just actually, calculate the position ourselves. Okay, for integer I equals 0, it counts I below dot counts. I think for array signs is counts. Okay, so we do it a for loop. Okay, so I mean there's one way to do it is to do a tuple, but I'm not too sure that the tuple type is already encoded in .NET 4.0. Yeah, so we could do this, and then we will basically set the visited stickle x I plus spelled wrongly, obstacle xi plus obstacle y I times max I plus 1 equals true. Yeah, so basically these are all the positions for the trees. Okay, and then we will then set the obstacles, and then we set all of them to be visited. So error, in does not contain a definition. Okay, so it's a length, it's not count this length. The name max I does not exist. Max x, yes, max x. Or it's actually x max, not max max. X max plus. Okay, so the hippo, let me just bring it back to 0, 0. Help me, help me. The hippo is running after me. Help me. Help me. Okay, so next up, we probably need to add in the animations for the hippo. But the animation is honestly pretty simple. Okay. So yeah, I think breath first search is good enough. Look at how scary the hippo is. Okay, so now we just need to add in the and oh, I won. Okay. Yeah, so we just need to also we need to call in the flashlight. When the hippo hits the flashlight, the hippo should walk in the other direction. So now this is good. This is good. I think as you can see, it's like not going the trees anymore. So I think it has already like learned its lesson not to enter the tree. I think the speed is decent also. Let me just show you how scary this can be. Look at this. Look at this. Oh, okay. Main camera. 2.15, I believe. 2.25. Right. Are you ready? Are you ready? Oh, I've got to find the crystal. I've got to find the crystal. Where are the crystal? Where's that? Ah, the hippo. Oh gosh, this is actually quite scary. Oh my gosh, I died. Oh gosh. Yeah, so yeah, I think the let's just put the camera back because I'm not done with the okay, so I think the game is more or less hippo walks a bit slow. No problem, we can make the hippo walk faster. Yeah, so what's next for this? Okay, probably I'll do it tomorrow during my usual stream session during 4 to 6. I need to make the hippo um change the animation. So I think Minhan has helped to do the animation for the hippo already. Hippo idle, walk down, left, right, up. So when to do this hippo animation? Okay, so we're just gonna call the animation here. There we go. Yeah, if the direction is up, is 1, 2, 3, 4, then we can start the animation here. Okay, so there needs to be a variable in the animation that gets triggered, maybe a boolean variable, or it could be a trigger. I could call the trigger to the animation here. Okay, and then it will basically give the right animation for the corresponding directions. And then if let's say the direction is 0, then we can trigger the animation of idle over here because we do have a hippo idle. Yeah, so we play the hippo idle is just one sprite. Okay, I cannot view it here unless we go to the enemy here. Okay, and then we go to the animator. Yeah, I probably need to select the hippo here to see this. Can't remember how to like is it build generic, but no it's not. Yeah, there's a way to view the animation preview. I think it's under preview animation controller. I forgot how to go to the animation, but pretty sure there's a way to like see the animation from the. Yeah, it's okay. I'll figure it out later. Yeah, I've got to go already. Yeah, but so far, what we have done is we have managed to make the hippo move to the player. Okay, it may not be just the player. It can also be the crystal. So the hippo does move to the crystal or the player, and it's kind of avoids the trees right now. So this is a good going at it. So what needs to be done next is to just put the hippo. Okay, we just need to put the hippo into the right animation when the hippo is chasing the player, and also we need to implement the state machine. So for this game, the state machine is very simple. When the hippo moves to the when you touch the crystal, the hippo will move to the crystal, and then once you collect all crystals, the hippo will chase the player. So this is the end state for the hippo, and then we need to code a random state where the hippo just moves up, down, left, right randomly. Yeah, so these are the various states that need to be created. Oh, you died. Yeah, so this is all for the breakfast search part, and yeah, if there's time, I'll do an A star search, okay, on a separate session because A star search, I'll need to implement the priority queue myself. Yeah, we have to assume that there's no priority queue in C sharp. I could just copy and paste one of the priority queue implementations that people have done for C sharp. Yeah, it is not very difficult actually. A star search, breakfast search is easy because breakfast search in this case, due to the connectivity of this map, breakfast search will reach the target very fast. It expands out linearly, like one by one, and then like the moment it hits the target, it stops. So breakfast search actually is quite efficient already. Okay, in this case, because there's no like dead ends or anything. Yeah, so this is idea of breakfast search. I can delete this whole thing. Okay, it is working. Okay, which is a great thing. So we just do a breadth search, and then based on the breadth search direction itself, we can then tell the hippo where to go next. Okay, next up, let me just add a to do. Next up, add animations based on the hippo direction. And that's it for today's session on the AI. You have any questions? Yeah, if not, I've got to go, and yeah, we probably continue again tomorrow. Okay, I hope this has been useful to some people. Okay, yeah. So today I didn't really do A star. I did breakfast search, but to do A star is just basically to um over here. Yeah, A star search uses a heap and has a priority uh has a priority number. So, so take out the node with highest priority. Yeah. So in order to do A star search, when we add in the when we enqueue the node over here, we will need to enqueue with a with a priority, and the priority is based on the current distance that we have traveled plus the estimated future distance that's estimated by Manhattan distance. So you just need to add the priority here when you enqueue it, and the current distance we probably will need to just create another integer array to just store in the cost of basically like how many steps have been taken to reach that position. Okay, we can also do an A star search like that. Yeah, so if you are interested, I will be able to code an A star search in another video. Yeah. So today we just did a very simple breakfast search just to make sure that it works. Okay, I'll focus more on the elements that are more important for the game first, like the hippo's animation, and then doing the state machine for the hippo, like doing the random movements, doing the um, chase the crystal, chase the player. Yeah, so all these state animations are sorry, all these states of the hippo, I'll code it out first. Then A star search probably a separate time. Yeah. Okay. If not, thanks everyone, and see ya. Thanks Minhyun for coding out the template. Yeah, it's a very nice template for this. All right. See you everyone.